All right. So we've had a little bit of conversation already about elements and compounds. Elements are collections of nucleuses, protons and neutrons, with electrons around them, whereas compounds are combination of elements that give us different properties. We also kind of informally introduced chemical formulas like this. Water, all right, H2O, there's two hydrogens, that's what that subscripted 2 means, and one oxygen. All right, glucose here is a compound which we talk about a lot. C6H12O6. This is the chemical formula for glucose and a lot of other sugars as well. Okay, so um, the elements and compounds, um, elements come together to form compounds, but compounds can be broken down into their elements as well. All right, sometimes that's something that happens. An example of this is a compound called mercury oxide. You heat the mercury oxide and it breaks down into mercury and the oxygen leaves, right? So you just get mercury and oxygen in their elemental form. Okay? So now we want to talk about classifications, how we classify different compounds or different materials. All matter can either be identified as a mixture or a pure substance. If it's a pure substance, that means it's either an element, meaning that all of the atoms in the system are the same, or it means a pure substance can also be a compound. All right? So a pure substance can be a compound, like water, right, is an example of a compound. It contains more than one element, but every unit in this container of water, for example, right, every unit of it contains an oxygen and 2 hydrogens, has that chemical formula. So that is something that we can identify as a pure substance. All right? A mixture, on the other hand, a mixture is a mixture of either elements or a mixture of compounds, and it can be identified, a mixture can be identified as either heterogeneous or homogeneous, depending on how well the mixture is mixed, right? So a homogeneous mixture means that all of the areas of the mixture, the vessel, the container, the amount, are all the area is equal in terms of the concentration of the different components. All right. So here, this is, can you tell what that is?
It's like juice or something?
Yeah, it's Gatorade.
Oh yeah, Gatorade. Okay, yeah.
So if I were to look at a section of this juice, this container right here, this Gatorade right there, uh, what kind of compounds might I find in here?
Sugar.
Okay, some Gatorade contains sugar. What else?
Um, is there protein?
I don't know if there's much protein in here, but there's, what's the main component? What's the main thing in there?
Oh, just water.
That's right, water. Water, sugar, and there are some salts. You've heard of electrolytes. You know, those are just salts. Those are ionic compounds in there. And that's a good review. Do you remember how we identify an ionic compound?
Um, let's see. An ionic compound contained. I can't remember. What was it?
Ionic compounds contain metals. What do you call the ones that don't have any metals in them?
Those are molecular compounds.
Very good. Excellent job. So, in this section of Gatorade, the amount of the different components is the same wherever you look. All right, and that's an example of a homogeneous mixture. Homo meaning the same concentrations of the different compounds or components in the mixture. Okay, in a heterogeneous mixture, now this is an example of oil and water mixed together, or vinegar and oil, right? Vinegar is a solution of water, and oil is a compound that doesn't mix with vinegar. Therefore, you get a heterogeneous solution. The bubbles are all oil. Outside of the bubbles, it's going to be mostly water, right? So if you look at different parts in this mixture, you will see different concentrations of the different components. And that's what makes a heterogeneous mixture. Okay? Have you ever milked a cow, Fred?
Yeah. Well, I tried. I saw someone else doing it once.
Okay, very good. Um, when you milk a cow, the milk comes out in a heterogeneous mixture. Okay, what do you think is the main component in milk?
Protein?
Mm, almost. Protein is one of the components. What's the very main component? What's the thing that we drink if we're going to drink something?
Oh, water.
That's right. Water is always the main component in stuff that we drink. So milk is mostly water. It does have protein in it. It has fats. It has salts, right? Ionic compounds. It has some molecular compounds as well. Okay? So it has lots of different compounds in it. But when it comes out, the fat all gathers at the top, and we call it the cream, right? And down below, you have a very watery material, right? Milk, this is milk, is a heterogeneous mixture. But we homogenize it, right? We homogenize it by shaking it up really, really well, and that's the way we like to drink milk if we drink it on our cereal or something like that, right? So homogenized milk means that they have mixed it up well so that the protein, fat, and all the different components in the cream here are mixed well with the aqueous layer. Aqueous meaning water. All right? Okay, so homogeneous mixture, heterogeneous mixture, pure substances, elemental or compounds. All right, so here's your chance. Here's your opportunity to look here and identify which of these represents a mixture of elements. Okay, so I'm going to allow you guys to pause the video and take a look at this and try to work hard on it and see what you think, okay? All right, Fred, they're done. They came back. They're done. Tell us what you think.
Elements? I don't think any of these are just a mixture of elements. I think there's something wrong. Are you sure you're asking the right question?
Well, what do you mean?
Well, like number 2 has one element, but it's the black dots, right?
That's right. That says it's an atom of one of the different element, and this is an atom of an element.
But why are they coming in pairs?
Oh, you mean the white ones there?
Yeah.
Oh, remember when we talked about elements could be diatomic in nature?
Oh, okay, yeah, okay. Well, then let me think about it some more. So it looks like 2 is our answer.
All right, good. 2 is an example of a scenario where you have a mixture of elements. Well, but what about 3?
Oh, yeah, 3 is a scenario as well where they're both diatomic.
That's right. So 2 and 3 are scenarios where we have a mixture of elements. Okay? Now, what about this one here? What's going on here?
There you have, is that a compound?
That's right. It's going to be a compound, this black and white one, right? Because we are mixing 2 different elements together. Now, what would these 2 white dots, what did we decide this was?
Those are elements.
That's right. Those are elements. So this is a mixture of what?
Compound and an element.
That's right. Compounds and elements. How about this?
That's a mixture of elements. No, wait.
It's just a compound, isn't it?
Yeah, okay, it's just a compound.
So this is not an element. This is a pure substance. Can you see that?
Okay, yeah. But they're different elements.
It can be different elements as long as all of the units, whether it's a molecule or an ionic compound or whatever, have the same formula, then it will be considered a pure substance. All right, here's another one. What is this a mixture of? All right, push pause, take a break, and come back.
I think I know.
You do? Tell us.
This is a mixture of 2 elements and 1 compound. Is that an answer down there?
Yeah, 1 compound and 2 elements?
Yeah.
That's right. Very good. You can see this is our element again, and this is our element as well. So there's 2 elements, and this one is our compound. Very good. Okay. So how about this one? Which box represents a mixture of 1 compound and 2 elements?
Okay, that's going to be number.
Okay, give everybody a second at home to look at it.
Are they ready?
They'll push pause if they're not ready. Okay, so they should be ready by now.
All right, so it looks like 2
That's right. That's right. 2 is the correct answer because this box 2 here, because we needed one compound, that's this one with different kinds of elements in it, and 2 elements. And these are different elements, the white and the black and the black, because they're diatomic elements, right?
Yeah.
Okay, one more here. Which of the following is not a mixture but is a pure substance?
Not a mixture, but a pure substance. Um, can you have two pure substances?
Which ones have 2 pure substances?
3 and 2 and 4, all of them have two pure substances.
Okay, but I think we're after a single pure substance, right? Because those are mixtures, right?
Oh yeah, the mixture. So number 1.
That's right. Number 1 is the answer there. It is a pure substance, and some people might say, no, it's not pure. It has 2 different kinds of elements. But compounds that have multiple elements in them can be pure substances, right? Okay. Which of the following element is not found as a diatomic molecule in nature?
I can't remember this one.
All right. So let's bring in our periodic table here. All right. Um, which ones are diatomic in nature? It's hydrogen, right? Nitrogen, oxygen, fluorine, chlorine, bromine, iodine. Sulfur sometimes will be not just diatomic, but have um, many atoms coming together into molecules. But these are our diatomic molecule or diatomic elements that we have to remember. Okay, so which one is not in our list right here?
He. What is He?
That's helium.
Okay, yeah, helium.
Very good. Is not diatomic in nature. Okay, excellent. That's a good place to stop. Good job, Fred.
Well, thank you.